Hello, everyone. This is Chris Kopak, Assistant Vice President at the University of Arizona of our Facilities Management Department, and also APA President. Sorry, we've just started just a couple minutes late. We have a few technical issues. Here we also have in the presentation, I'll let him introduce himself.
I'm Henry Johnstone, President of GLHN Architects and Engineers.
And so Tony Guerrero, who you all know Tony very well, is on the APA board as a treasurer and also membership vice president. I know Landra Medlin had done a presentation about a month or so ago to a number of you business officers for our community colleges. And Tony wanted us to follow up further regarding some webinars we've done for APA on infrastructure planning, utility road mapping, and also funding. And what we'd like to do, though, before we go ahead and start, we'd like you to go ahead and send us any questions. On your screen, you should be able to have a dialogue box. This presentation will go for an hour and a half. We're planning on roughly about an hour, 15 minutes presentation. But we do want to interactive. We want to make sure you're getting as much out of this, any questions that you have. So if we can just pause for about 2 minutes. If you have any questions at all, go ahead and type those in, send those to us, and then we will make sure the presentation, the PowerPoint is tailored to your needs so that you're really getting a lot of good information. And then also throughout the presentation, if you have questions, feel free to go ahead and send us questions through the dialogue box. So we're going to pause just for 2 minutes. We'll get back on at 11:06. Thank you. Oh, perfect. We're getting a number of questions that are coming in. And we have roughly about 22 folks who are on the line. Again, this is Chris Kopak, Assistant Vice President of Facilities at the University of Arizona, and also APA President, Henry Johnstone, President of our GLHN engineering firm. We're going to keep this, we have a formal presentation and we'll go through the slides. But we really want to make sure that you get as much out of this as possible. APA has great opportunities to share information. We're doing monthly webinars. That's one of the #1 items our members were asking is give us back items that would be helpful in running your operation. And as chief financial officers, the challenges is funding. A couple of questions coming in. Wayne, thank you for the first one. Ideas for getting funding, prioritization of infrastructure before it breaks. We will be going through some challenges, some real life challenges that we've had at the University of Arizona, and also how we've been able to come up with funds in the tune of $400 million. $200 million is being used for 2 research facilities, and we'll use $200 million to address some aging infrastructure mechanical, electrical, plumbing, deferred maintenance needs, and others, life and safety needs. And we'll touch base on that. David has also asked, is there a list of best practices and resources available for campuses responsible for individual transformer maintenance and replacement versus a utility-supported transformer? Well, that's a great question, and again, we're going to use a lot of real-life stories here in the presentation, but we do want to tailor it to your needs. At the University of Arizona, you're talking about transformers and electrical systems. We had a major challenge just last week in which we were in the process of replacing some aging electrical infrastructure, switch gears, transformers, and then the final component was to splice it into some aging cables. It was determined at the time the cables would be sufficient. As Murphy's Law would have it, it was not. It did not hold, and it caused an outage where we had to bring in 2 large generators. But the staff worked throughout the midnight hours, did a great job, and got the building back up and running in one day, and replaced 3 lines of 400 linear feet of cable. And so that is a challenge all of us are going to be having with our deferred maintenance. And I don't look at deferred maintenance as being a bad word. We're going to talk today about having a good understanding of your needs. The utility capacity review that we do at the GLHN, we do that on every 4 or 5 year basis. The purpose of that, when I've been at the university 22 years, been in the facilities field about 36 from the University of Michigan Hospitals, contract services. But when we look at our aging infrastructure, like baby boomers, our buildings, we had a large growth after World War II, and what we're seeing now is all those mechanical, electrical, plumbing systems are aging out or they've already aged out. In some cases, with a campus that was built in 1887, we have systems that are double the lifespan, and we need to plan for that. We do a 10-year analysis and then make sure we have plans with our utility capacity review that's done every 4 to 5 years. And then we use that as a roadmap to secure the funds. And as Wayne had mentioned, prioritize those key items before it's critical failure. Because the trick is always the continuity of operation at our universities and colleges. We don't want to see the disruption. We want to see that we have solid plans in place. And occasionally we're going to have some challenges, but then even with the challenges, how are you going to address it? We have another one here that has come in. Our systems have been distinguishing between building systems and infrastructure outside of the building. Can you let us know when referring to buildings versus other infrastructures? We will. And so maybe throughout the presentation, Henry, that we will talk about our utility distribution systems. That is basically from, if you have plants on campus, I know some of the smaller colleges may not, but if you do have a utility plant on campus, chilled water, steam, boilers, and even cogeneration up to the building, and then the building itself then would be the mechanical, electrical, plumbing systems, along with the structural, roofing, and other items, and life and safety, which we're talking about are elevators, fire systems, and such. So with that said, the dialog box, it looks like it's working very well. Brett, thank you. And again, we want this interactive. We want to make sure we've allocated an hour 15 minutes for hour and a half, actually, but a lot of questions. So as you have questions come up, we're going to mix them in. We'll pause for a sec as Henry or I'm talking, and we'll address the questions. And we have another one, Henry, from Brett. And, you know, it's always a challenge when we have a larger group on the call. And so we do have a 22 total. We've had these webinars, I'll say, and again, giving back to our members. And you've met Lander already. And as APA president, it's been one of our main themes of giving back. Harnessing the knowledge and transferring that knowledge is really the theme. So throughout the year, we've had literally webinars with over 700 attendees. And so the dialog box works well. Brett also asks, what criteria do you utilize to determine the priority for your deferred maintenance? And so, and when we're talking utility distribution system outside the buildings, from the plants to the tunnels to the building itself, I know at the University of Arizona, we're doing routine facilities condition assessments for the buildings, but our utility distribution system Henry, I know we're going to jump into the PowerPoint, but we'll address this. When we do our utility capacity review, maybe just give a brief on what are we looking at on that utility capacity review on the systems.
Sure, yeah. So part of our process here that we'll get into in a minute are these capacity reviews where we're really looking at all the components and elements of the infrastructure and how it ties into the buildings, because you really can't think of this as two separate things. Here's the plants and distribution, and then on the other hand is the buildings. It's all one integrated whole, and you really got to look at it as an integrated whole. So part of what we do is an evaluation of the condition, the reliability, the safety of all of the components in the system, from where it comes in the meter, from the utility company, to where we run it through our plants, to where it goes through the tunnel systems and out into the buildings. And that involves, I think, in some cases it's outside consultants and experts. In a lot of cases, it's the in-house staff, the plumbers, the fitters, the electricians, the guys who really know what's going on, and carefully questioning the current knowledge base and trying to get it down on paper.
I think as we go throughout the presentation too, we'll continue tailoring our comments to the business officers because you have a challenge. Your job is to have a good understanding of what's being presented to you from your facilities staff. We want to have, and APA has a great opportunity for all our facilities officers to educate them, provide great training, and then to make sure that we're making solid decisions. And our utility systems are not a couple $100, even a couple thousand. I mean, they can range from hundreds of thousands, if not millions of dollars. But on a routine basis, so we're looking at that return on investment. We're looking, when we're doing utility projects and prioritizing those, first and foremost, we go to our utility capacity review to look at our campus as a whole, tied into the strategic mission of the university or the college. And then as the campuses and colleges are growing, what is it going to take to achieve those goals? And you want to have a good understanding where your electrical systems are, your chillers, your steam system, cogeneration. Out here in Arizona, we have thermal ice because it's so hot. We're trying to cut our peak. On a side note, too, we have a Pac-12 consortium that we get together with twice a year, along with other benchmarking, sharing information. We look at our gas purchases, our natural gas purchases, and that could be an opportunity, too, and we could hold a whole nother webinar on that. But our gas purchases, when we look at our utility systems, the commodities at the University of Arizona, we're spending roughly about $14 million just on electricity, and roughly about $11 million on natural gas. And so that's another component, like mutual funds, that we go ahead on a routine basis and buy strips of natural gas. And we go ahead and at one point in time, it was $8.65 a therm. We now are buying natural gas at $2.85 a therm. And we're pushing it out through 2022. We buy certain percentages of that. And so that's an opportunity to have a conservative portfolio, but it's a large cost that you can go ahead and rein in those costs and have some predictability as you're setting your financial models 5 years out and beyond. Also, going back to the question of what criteria to utilize to determine the priority of your deferred maintenance. From the utility side, we set our utility projects based on our roadmap, our utility roadmap, and then we go ahead on a routine basis, weekly basis. We are reviewing our utility systems. Myself as the AVP, along with my AD of utilities, along with the staff, superintendent, and others. And then we prioritize our utility needs, not just once a year. We're looking at them throughout the year because it evolves and changes. And we have priority 1, 2, and 3. We have a component, a cost component on that. And then we use that for long-range planning as I'm working with the chief financial officer, the chief budget officer, and we're looking and saying, all right, we need to allocate X millions of dollars to our utility system. And that utility system is also our tunnel system. And so the tunnel distribution system, in our case, we have some challenges, and GLHN has helped. And maybe, Henry, I know we're going to get to it, but we'll continue addressing some of these questions.
Sure.
And again, we want to make sure this is very helpful for you, not just a PowerPoint presentation. We want to address a lot of questions. But Henry, you all do in the utility capacity review, you assist us with analyzing our tunnel systems. I know we have some slides on that, but what does that consist of?
Well, that consists of sending guys down into the vaults and the tunnels, documenting existing conditions, photographing. We've built a BIM model in some cases. We've taken video, really getting into the weeds, getting into the nuts and bolts of it, identifying what the problems are, and assessing what the individual discrete costs are to replace, repair, renew. It's really a hands-on kind of effort. I want to reiterate, though, having outside consultants is what we do. We've got some expertise here, but having your own folks involved, deeply involved in this process, is very useful, and we're able to communicate both ways. The shops folks understand what we're seeing, and we understand what they're seeing, and together we come up with a really good list of priorities. Here's what has to happen first, second, third. Here's where your big risks are, and here's what your opportunities are.
Perfect. And then when we take it into the building systems, from the building into really roughly about 73% of the systems are behind the walls, mechanical, electrical, plumbing. I mentioned earlier about if we look at the age of our campuses, at the University of Arizona, we have a portfolio of buildings that are between 50 and 60 years that is roughly about 2.8 million square feet. When we look over the next 10 years, we're adding on another 5.8 million square feet that are coming into that 50, 60 year range. And actually, if we look out over the next 20 and 30 years, we have a large amount of square feet that's aging out. And so it's critical that all of us are putting good plans in place to address those systems as good stewards. So if there's not any other questions, I really appreciate Wayne, David, and Brett for sending some questions. If you have any other ones, it seems like this is working well. Please go ahead and type them up. We're going to go ahead and start with the presentation. So at the University of Arizona, we're a land grant university, a research university that has established in 1887. We have over 43,000 students on campus, roughly 11 million square feet. I have 600 plus facilities management staff. We cover the whole gamut. From our utility systems, we have 3 plants on campus. I'll review that in a second. We produce roughly about 36,000 tons of chilled water. And we have roughly about 55,000 faculty, staff, and students here on about 500 acres in the Southwest. You know, at all our universities, it's critical that we have the proper funding, and it's critical that you have the right philosophy on your facilities management teams. The culture of your team, we at the university like to say we have one team. One team taking care of our faculty, staff, and students. The job of our facility staff is to graduate students, help them get their degree, create that atmosphere from our grounds that they can relax and study. We have finals coming up next week. We want them to be comfortable inside the buildings with air conditioning working properly. We're aggressively updating our classrooms in the tune of $2 million last year, another $2 million this year, which we're in the process of starting those right after graduation, a week from Monday, to really create that student experience while they're here. And so it takes one team to do that. We like to say our 3 themes besides the one team is we run it like a business, but we run it as a family business. The staff cares about each other, they care about the campus, they care about the faculty, staff, and students. And by doing that, you can show that in the quality of work they do. And then the third theme is just can-do attitude. We need to make it happen. If there's emergencies, we got to get it done. The small stuff, the big stuff, everybody comes together. We're very proud of our sustainability efforts. So we continue working on enhancing our sustainable efforts. And as we're talking utility systems and also mechanical, electrical, plumbing, we're also looking to say, how do we go at zero emissions in our building? Is that possible? Which we said, yes, it is. And what's the frequency? And so I know as financial officers, that can be a challenge of what is the commitment in terms of dollars to achieve net zero emissions. Is it by 2030, 40, or 2050? And we put plans in place to go ahead and do that. And you know, you can do a lot of stuff. It only takes money. So that's a challenge. But we got a great team. You'll see one slide there in the upper left-hand corner talks about our award for excellence. back in 2013. I got to put a little plug because I'm real proud of our team. We just had our APA site committee out here, just finishing up, matter of fact, today, looking at the award for excellence for the next 5 years. So we'll wait to see what happened, but we think it was real positive. So, and we do that for our staff. Next slide here talks about our utility roadmap.
Yeah. Okay, so we'll get into some of these slides here, but again, as Chris said, let's make sure if you got any questions as we go along, send them in. We'll try to respond to them. So what is our utility roadmap? What is the process? Well, GLHN's been around for 50 years, and we've been working for the university for almost that entire time. Myself, I've been here 30 years, and so I'm fortunate enough to have seen a lot of change on this campus. And what we're setting up to talk about today is a process that just probably over the last 10 years has really been developed to kind of a continuous improvement process for utility planning and infrastructure improvements. So the process, we start with what's the end in mind? What are we really trying to get to? Build a vision statement. The next step is computing the metrics. And we got a few slides about this, just the importance of actually knowing the data, having access to data that you trust, data that makes sense, data that you can act on, computing metrics. The next step here is reviewing the current state. This is what Chris talked about, our periodic capacity reviews. That's just going back and carefully looking through all of the components that make up utility infrastructure. I think what's important here is that you look at this thing as a cohesive whole. Rather than reacting to individual problems with utility systems, you say, let's look at it all. Let's evaluate everything we got and try to then have a database on which to make informed decisions.
Go ahead, Henry, and I'm jump in.
So once we've kind of got we got the capacity review, then there's some brainstorming involved. What could we do in the future here? The three big drivers for utility investment, growth is certainly a big one. There's been a surge of growth here at the university, big new buildings going up, research labs, that sort of thing. So growth adds load. You got to have capacity to serve that. Technology is another one. Aging technology, old equipment that's wearing out. And then finally, another thing we look at carefully is, because there's opportunities here, is do you necessarily buy all your utilities from outside sources? Do you buy electric power from the power producer? Or is there a chance that cogeneration works? Here at the university, cogeneration, where we're buying natural gas, creating electricity, and making heat out of that, has really been an economic boon. To a large extent, has enabled funding other critical infrastructure.
And Henry, that point number one here, in terms of describe an end in mind, as a financial officer and partnering with your senior facilities officer, it's critical that you're both on the same page. You have to have that good, solid baseline up front. At the University of Arizona, we'd like to be one of the best utility providers of university campuses. And as I was talking to my staff, I said, let's look and benchmark universities throughout the country that are doing it very effectively and efficiently. What are they doing, and how can we bring that back to the University of Arizona so we can be as efficient with every penny? And we've had success stories where we're using a benchmark of a 2012-13 as analyzing our $34 million at the time, and we've been able to cut our utility consumption, or our utility costs by millions of dollars. And it's having this benchmark right off the bat of understanding where are you currently at with your entire utility systems. And then also, as we got questions about deferred maintenance, we also do a benchmarking on our deferred maintenance on an annual basis. So we have a very solid idea, and actually we do a 10-year plan on our building deferred maintenance, so we understand the systems that are pending failure, going back to Wayne's question before it breaks, and then we put a financial model in to address those.
Right. So yeah, final step is once you got an idea where you're going, prioritize, and it's an iterative process. All right. So why do we do this? I think a key role is stewardship. I think Chris talked about the fundamental role of utilities is accomplishing the university's mission. Lots of money is involved, lots of assets, lots of capital expense and operating expense. And then finally, this idea that almost 75, 80, maybe 90% of the campus energy, water, carbon footprint run through the utility system. So really, it's the utilities that have most control over the sustainability aspect of campus operation. But finally, why do we do this? I think it really has a lot to do with being able to articulate the needs and to communicate those to the folks that are going to be funding infrastructure. Clearly, there's a lot of competing priorities, research priorities, academic priorities, other priorities that infrastructure not quite as sexy as some of those things, and it's really important that you have a very clear story and the data to back it up.
It might not be sexy, but it's critical too, just like the research, just like what's taking place with all the education with the students. The infrastructure has to be solid, so then all those great researchers can get out there and provide great information or great teaching.
Yeah. Okay, so how do we do this? Well, here's my little animation here. Roll out the toolbox. So there's a whole lot of elements that go into a utility master plan and the roadmap process. And I, again, want to kind of reiterate it's very important that you look at the big picture. You start big. You start at 30,000 feet. Look at everything and dial yourself down. Some of the key things I think need to be part of this process. You see the little drawers on my graphic there trying to indicate what the elements are. The comprehensive campus plan. Do you have a plan that talks about what the growth is going to look like? Is real estate going to be added? What's the campus carbon action plan if you're responding to that? That's been a big deal of late. But there's many other more technical kinds of things, structural evaluations, mechanical evaluations, electrical. I think I want to just end this with going down to the bottom drawer, the bottom left-hand side there. And again, this is a key part to the success of utility planning, is pulling out the big tools there. That's the folks in facilities management, the knowledge base that's currently on campus that knows how things work, where the buried valves are, what the last leaks in the system were, and how they got repaired. So really having an in-house staff involved and engaged in this is critical. Okay, so we'll go back to the steps here and just kind of briefly summarize some of these steps. This actually is almost exactly what Chris was talking about. The end in mind at the University of Arizona is to hold utility costs constant as the campus grows, which means driving the cost per square foot down year over year. And what we're seeing in this image on the left-hand side is kind of the history up until from 10 to 16. What did the overall utility cost look like? And from that, we're able to kind of extrapolate out and say, okay, this is what we can expect to do over the next 10 years.
And Henry, you're spot on in terms of the cost per square feet. And as you're starting to see, near and dear, I'm sure, to your heart, is if you can't measure it, you can't improve it. And routinely, we have to be able to measure that. And Henry's going to talk in detail about that. But the cost per square feet at the University of Arizona, our utility costs, which we benchmark on an annual basis, is we are able now, with analyzing our systems, making adjustments in our plants, our tunnels, our building, our square footage cost is lower today than it was over 16 years ago.
Yeah, and we'll see that.
And that's a credit to our hardworking team. I'll put one other notice too. Henry, you were talking having the staff internally who understand the systems. We currently have an apprenticeship program, federally approved, actually nationally award-winning. We're real proud of our staff. And the fact is, we've completed one whole class, 4 years, graduating electricians, plumbers, HVAC. We've just started another class. We have 9 gentlemen who are completing their first year of 4 in controls, plant operations, electrical, and HVAC systems. And when you have that internal staff who understand your systems, that helps overall driving down your cost.
All right, the end in mind. Now we look at the compute metrics. And what do we mean by metrics? Well, this, you start out at the high level. What was our total consumption of power, cooling, heating, water, in sort of engineering units, and then drive this down into increasingly more granular data. Break it down into the monthly amount of chilled water that we consumed, the potable water consumption year over year and by source. So really the computing metrics involves looking at data, analyzing data, and then coming up with ways to compare this year to last year, this month to last month, this year to 16 years ago. Now this is the famous quote, if you can't measure it, you can't manage it. I did. It's preparing for this PowerPoint.
Henry, I jumped the gun a little bit on that one, but I'll tell you what.
No, that's okay.
I'm thinking of our audience, and near and dear to their heart as it is to ours too. If you can't measure it, you can't improve it. So
I stumbled across this, which was the original quote, which I thought was kind of cool. This is Lord Kelvin, the bearded dude there, 1883, and he goes into, if you cannot measure it, then you cannot express it in numbers. Your knowledge is of a meager and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the state of science. That's just like poetry. I mean, that's what the guy originally said, but the reality is absolutely true. Without the data, you have no way of knowing what you should be doing. So what does that mean to us as facilities folks? Well, data is in the utility bills, plant operating logs, equipment histories. Oftentimes that's information that's on board on the piece of equipment, building data, metering database. And so there's a vast amount of data. The important thing is you're able to access it and organize it in such a way that you trust. When you call it up, I can trust this. This is the right information.
And Henry, you're spot on in terms of the data. At the University of Arizona, we are very big in harnessing that data and running our operations. And so within the utility plants, to make sure that we have those key performance indicators, our facilities officers, our employees, our supervisors, superintendents, we all have them on a routine basis present back to us. So we're all on the same page that they're looking at the economics of our utility systems, running them as effective and efficiently as possible. Do they understand all those key measurements we're looking at on a monthly basis? Working with my business services staff that report to me, we have a variance analysis that is reviewed. We can look at our electrical, our water usage, our gas usage, our solar usage. We can look at a project that was put in place and we look and say, is there a direct correlation of the 5,000 linear feet of insulation that we put on a steam line that did not have insulation, and once we've done it, we saw $1 million worth of savings. You see a direct correlation. Or the SCADA system that was put in our well system, so we can measure all our water usage on campus, and we saw benefits of making adjustments on that. And just clarifying too, I mentioned about an apprenticeship program. We have an apprenticeship program at the University of Arizona. We have graduated our first class a year ago, and we now have another class that's finishing year 1 of 4. And so that is a major item too. And one thing I'll put out regarding the question that was asked on best practices, that you can go to the APA webpage. We do a monthly webinar. This is a kind of off cycle a little bit, but we do a monthly webinar the last Thursday of each month on many different topics. We've done it on apprenticeships. We've done it on microgrids and such. Henry, you've done one also on our deferred maintenance way up front. You'll see, you'll be able to access a PDF copy. You'll have best practices, and you'll have the audio on those. And again, after this, we're going to make ourselves available. If you have any other questions, you'll have our contact information, and we can schedule a call just to chat. Henry?
Okay, so here's the sort of data that we need from the billing. This is what Chris's group calls variance analysis. So this is 17 years of all the utilities. This sums up to the $28 million that was referred to earlier. So year over year, each of the components broken down, compared, how much did we use, what was the cost, and if you see on the bottom right-hand corner there, you see what we're talking about here. The price for overall all-up utilities per square foot at one time was $2.91. Been driven down kind of remarkably to $2.18. You know, even as the economy has changed and the campus has grown. Okay, so from there, from having this data, I think one thing we want to just say is a very important component of this is trying to figure out how the meters close. Do all of the individual meter readings and data you get close? So this really looks at what did you buy from the utility? What were the utility bills versus what the plant production says it was? And then the other class is, what did the buildings consume compared to what the plant was producing? I have a little graphic that kind of depicts this. So in this graphic, what we're seeing on the far upper left-hand corner are the purchased power. That's in units of energy, Sankey diagram in units of energy. So there's the incoming electricity. There's the incoming gas right below it. The incoming gas goes through the gas turbine system here at the University of Arizona. Some of it turns back into electricity, the rest turns into heat. From there, it gets distributed down to the district buildings and then used in the buildings for turning on the lights and the computers and the miscellaneous. And also a big component of it, particularly here in Tucson, goes to the cooling plant for pulling the heat back out of the buildings. Well, we get meters. We have meter data from the utilities. We get gas meters. The plants are all now pretty well set up with production meters, so we know how much electricity is going through the main substation, what the main switchgear is doing. We know how much heat we're making, how many pounds of steam, and we know how many ton hours of chilled water we're making as well. Finally, though, we have building meters, and just in the last few years, a big initiative to really up the game of the building metering program. So of the 190 buildings that are metered now, it's reliable data. We actually can trust that data. We can sum that up and compare it to what the plant is and get an idea of what the distribution losses are.
You know, Henry, when you talk about meters, way upstream, we were not able to measure everything that we needed to. And going back to that quote, if you can't measure it, you can't improve it. And so we have over 800 meters on campus now. That's critical for our research buildings, for our federal grants, that we have the accurate information. And then we went ahead and invested in software programs that literally allows us to be able to, and the technicians, to be able to come in on a daily basis, have an electronic notification if any of those meters have failed. And then what's critical too, and actually we partner with GLHN on this, on a monthly basis, because we also have auxiliaries. We're supplying chill water, we're supplying steam to a hospital. It used to be University of Arizona, it's spun off, but they still get utility systems through our distribution system and our production. Also our Residence Life, our Student Union, the auxiliaries. And so we do a meter verification every month. We look at every meter we have. If something is askew and not within the variance that's been established, we then can drill down further and find out what's going on. And it just helps the technicians greatly with electronic notifications they get, and then also the verification in terms of financial, that what we're charging our customers is accurate. Very important.
And maybe just to touch on one of the questions there, this little diagram really shows how important it is that you don't segregate. This part is the plants, this part is distribution, this part is buildings. It's all one whole, and you got to have your arms around pretty much the whole system, from where the steam gets created in a boiler all the way to where it gets used in the building. I think you just got to think about this in terms of kind of thermodynamic systems, not break it out into artificial little domains of who's got control of the plants, who's got control of the buildings. It's one big cohesive whole.
And Henry, that's a great point, because with the investments that have done in the plants, you could invest, as we have millions of dollars in the plants. You have to look at your distribution system. In our case, we have 6.5 miles of tunnels underground with our steam, chill water, and such. But then when you get to the buildings with the aging infrastructure, infrastructure inside the building, mechanical, electrical, plumbing, if you're not addressing that and putting energy efficient equipment in with your variable frequency drives, with upgrades to building controls for lighting and HVAC, you're losing opportunities and saving literally millions of dollars.
Okay, so once we've got a good set of data, I'll just go quickly through this. It's kind of an interesting way of presenting the data. This is every hour of the year plotted on a three-dimensional graph here from the main electric substation. This is the data we get from when we buy the power from Tucson Electric Power. So you can see on there, the actual surface itself is kind of like the instantaneous demand. Pick a day, pick a time, and look at the graph, and it'll tell you how much electricity the campus was using then. If you look at the volume under this curve, that really represents the total amount of consumption, the megawatt hours campus used over the course of the year. Well, of course, at the U of A, there's a couple of substations, a number of cogen machines. It gets a little more complicated, but you can sum this data. So that was the main purchase meter. Here's the secondary purchase meter. On top of that, we got gas turbines. Sum all this together. Now we have an image of what electricity looks like at the University of Arizona. What is the differences between a winter evening and a summer afternoon? What's the differences day to night, month to month? And this really is helpful in kind of visualizing the kinds of approaches you might take to infrastructure improvements. Same kind of thing happens with our heating demand. Here we have a very low heating demand in the summertime, but not zero. Still pushing out heat even in the hottest days of the year in Tucson. And then there's our campus cooling profile. So here's the next little set image, again, kind of touching on the interface between the utility systems and the buildings. Here's an image of the campus of the U of A, kind of an urban campus. How many buildings are there on this campus, Chris?
Yeah, roughly we have 136 main campus buildings, over 257 around the perimeter of campus.
Yeah, and they're all ages, all types. You know, research, a lot of research here, academic, residential, athletics, a big hospital up on the left corner there. And so what we're able to do, once we got really good meter data from each of the buildings, combine that with the square footage of the building, and really able to compare building to building the energy use intensity, EUI. So that's just a way of looking at annual energy use. That's all three sources, electricity, chill water, heating, over the square foot. Now what's useful about this, other than it's kind of a cool little graphic that spirals by, is it really allows you to compare buildings on campus here. You'll notice we've colored them, and of course a research building uses a whole lot more energy than a residence hall. So we're able to kind of identify by building type what do these comparisons look like. And I think this has been very helpful in terms of prioritizing needs. When you look at the diagram like this, and this one, of course, the horizontal axis on the bottom, this is chronological, starting from back when the campus was very young to now. As Chris said, there was a whole lot of growth in the 50s and 60s, and you can kind of see the square footage growth on this graph there. And you can see that a lot of those buildings are big energy consumers. Now you go up into the 90s and even the 2000s, and those big red high spikes, well, those are really intense research laboratory buildings, high energy users. So it's not just a matter of age, which you kind of see in the green images there, but it's also a matter of what the buildings are. So this gives you a really good way within the campus of prioritizing the most important energy targets. And it's on a building basis. But sure, it's on a building basis, but the infrastructure is feeding these buildings. And if we're able to make substantial reduction in building energy use, we're going to be enabling more capacity in the existing distribution infrastructure. So I wanted to talk about an APA initiative that I think is, in the next couple of years, going to be really important for universities here. And that's this Building EQ program that a partnership between APA and ASHRAE is beginning to look at universities as a whole, loading energy use intensity data for university building into a large database. So when this is complete, you'll be able to look at your peers. What are the best-in-class buildings of this particular type or this particular age? There'll be enough statistical data in there to really allow you to make informed decisions.
So we had an opportunity, actually early this morning, we had a conference call with ASHRAE, ASHRAE back in Washington, D.C. with APA, and that's the great partnership and the great resources that APA brings to all our members. Is that we have a lot of collaborative relationships. We've established a collaborative relationship with ASHRAE. As Henry mentioned, the University of Arizona actually is a pilot university for the BEQ program, along with several other universities throughout the country. But also ASHRAE is offering a number of different training opportunities. And so as we look at our staff, as the baby boomers are retiring and we have newer technicians and journeymen coming in and journey folks, journey ladies coming into our field, we need to make sure that they have the proper training. And ASHRAE is offering not only the training on an online program, we're establishing an ASHRAE training program in navigating our facilities portfolio at the APA Institute that we hold twice a year. And so the next one will be in September, that we'll be rolling that out. Transforming our grad program to navigating the facilities portfolio with some more detailed technical training. So there's great opportunities there.
Okay, so with good data, when you actually have reliable data that you can use, you can begin to create simplified view. I mean, the utility infrastructure is fairly abstract, technically complicated, sometimes hard to explain to administrators or financiers about what it is and why it needs to be invested in. So here we create a very simple kind of overall utility flow diagram that shows how much gas we're using, how much electricity, and relates it not only to the magnitude of the units, but also to the costs. And there you see the magnitude of the costs for this particular example here. Yeah, part of this kind of goes to the ultimate goal of being able to sell this. Simplify, simplify, simplify. Make it so that you can explain in an elevator speech with a couple of crisp graphics why it is money needs to be invested.
You know, one of the challenges, and Henry, you bring up a good point, is the marketing of the information. We talk selling, explaining, executive summaries, concise information. Look at our target group that we want to address. But the utility system is one of the largest budgets at our universities and colleges. And when we're talking just at the U of A of 34 million, when we can lower those costs, and then we mix it in with energy programs that we can take advantage of energy efficiency in the building, those funds can be self-filling in the sense that you can see energy projects, take those savings and kick them back into additional energy projects. And so there's a number of ways we can prioritize the needs and then establish a funding source to go ahead and continue addressing those challenges on our campuses.
So I talked about how important it is to simplify, but the reality is it's pretty complicated. And so here again is a sort of an overall diagram of how the utilities come in. On the left-hand side, this is what we're purchasing from the gas, a couple of different pressures of gas from our gas company, Electric Power, runs through the 3 plants. This is in each of the plants. There's chillers, boilers, cogen machines, thermal storage. How that gets processed through the plants runs through a tunnel distribution system, which we'll talk about in a second here, and then fed into the buildings. So now we talk a little about current state. So this is the piece that I think has worked out really well at the U of A, which is doing these periodic capacity reviews. Within this capacity review, there's sort of chapters. A chapter on production, which really breaks down all of the components, the chillers, the boilers, the pumps, switchgear, breaks them down. How old are they? What type are they? How many of them are there? What condition they are? And what are the issues with reliability? What are the known issues with reliability, and what are the potential issues with reliability given their age and condition? Same kind of thing for distribution, and we'll talk about that in a second. But again, don't just stop with the utility systems. Really need to take this through the buildings, if nothing else, the building mechanical rooms, and quantify what kind of equipment do we have in the buildings, how efficient is that, and how safe and reliable is it?
And Henry, I would say not just the mechanical rooms, it's the entire envelope of the building itself. Yeah. And so coming back to the questions that we've had from the utility distribution system that's outside the buildings, coming from our plants, coming from our tunnel systems, you have to prioritize. And so by having that baseline capacity review, and then we like to talk in terms of roadmaps. And so when we have roadmaps on multiple fronts with chillers, steam, several years ago we had problems with electrical capacity, some chill water capacity, some gas capacity, working with our local provider. Systematically, we then said, what are those critical items that we need to be addressing? And then working with our budget office, chief budget officers, establishing funds within our budgets, and then maybe some capital projects outside the budgets that then is being allocated to address those urgent needs. And it goes back to the very first question that Wayne mentioned, that we want to address items before it fails. And then you take it to the building, and the same process goes in place. Toward the end, we'll show you one of our slides that looks at a 10-year analysis of our entire mechanical, electrical, plumbing system, and what are the critical ones. HVAC out here in Arizona is just a huge one. Yeah.
And finally, another thing to include in this capacity review, and Chris touched on it, is the interfaces. what does it look like on the utility purchases? How much capacity do they have? What are their plans for serving the campus in the future? And also to look at utility sale. How much are you charging where you're charging customers for your utilities? Is that really equitable? So kind of going through the financial inputs and outputs of this is critical to the overall utility master planning effort.
And Henry, as you know, we could do a whole nother webinar just on the establishing of utility rates for our auxiliaries. So we have a good understanding. We talk in tiers on ours, from depreciation to the unit cost to the overall system administrative cost too. But that's for another day, another time.
Okay, estimating remaining useful life. So there's tables out there. ASHRAE has a table. The Office of Management and Budget publishes a table. The Air Force publishes tables of useful life of equipment. The reality is most equipment runs way longer than the table says. The table says an air handler is good for 23 years. We're dealing with air handlers that are 40, 50 years old. So it's not just a matter of looking it up on a table and putting the numbers down. I think it takes an informed, educated, experienced team to kind of evaluate, assess, and compare systems to each other. Efficiency is another one. You really want to quantify that. Huge cost driver here. And another thing not to overlook is the level of automation, the level of intelligence that goes into your operating strategies here. University of Arizona has recently had an initiative to really up their game on adding intelligence to control sequences in the plant. Kind of thing that doesn't take a whole lot of capital cost, but reaps great returns in operating expense.
Well, it did cost about $1 million only, but it did allow us to go ahead and harness the information coming from our chillers. And so when we have 22 chillers that produce 36,000 tons of chilled water, we want to make sure we have real-time data to make good decisions. And that data, as we've said, so we can measure it, that goes right to the buildings too with our building automation systems and our controls. So there's great opportunities when you have a good solid understanding of what's taking place in your buildings. Also, I know on the line too is not just our business officers, we also have our senior facilities officers on the line too. And so if you have any questions, feel free to go ahead and type them in.
Very good. Okay, so ultimately, what is the result of a capacity review? Well, it's a catalog. It lists out all the components you got, the deficiencies, where you're doing well, where there's room for improvement. A single document that's kind of got it all, that over the next 4 or 5 years you can look back on and say, are we making any progress in resolving this issue or that issue?
And Henry, the whole idea of us establishing a roadmap, we put a very concise kind of executive summary brochure together on our deferred maintenance needs, equating it to the health of the buildings. That goes back to conversations and travels with our friends in UK, where they have very, very old buildings. They said they can't demo the buildings, they want to rehab them. And so we work with GLHN, we put our data, our metrics together, and we have an executive summary in terms of deferred maintenance. And then the roadmap, in the detailed binders that take place, they're not just sitting on the shelf. We're making them actionable. And it goes back to the questions too about prioritizing. We're prioritizing those critical needs that could affect the continuity of operation. And then we're putting established roadmaps in place and allocating funds. And you can look out in some cases 5, in some cases we'll go 10 years. Past 10 years, that's really getting out there. But a 5 to 10 year plan is very solid and it's flexible. It's a living, breathing. It's making adjustments as needed, especially out in the Pacific West. I know you really have different climates out there, from the ocean side down into the southern part of the area.
All right, so I'm going to talk a little about the distribution system. Here's another kind of graphic of how the energy works here, the energy flows here. If you haven't figured out by now, I'm a mechanical engineer, and this is my kind of thing here, flow diagram. So when we're in the plants, we're looking at equipment. What you see up there on the upper right-hand side is a great big side-wheeler Crane R11 machine. The refrigerant's obsolete, out of date. The machine itself, efficiency is nowhere near what current technology is. This one aged out and now gets replaced with something way more efficient with a refrigerant that doesn't have any global warming potential. kind of thing with switchgear. So just a team that's going through, a team that it involves maybe outside experts, but in-house experts as well, really evaluating remaining life, efficiency, reliability. I'm going to talk a little about the distribution system here. So we start out with campus mapping, and this can be done a lot of ways. I think the way, in my mind, the most important thing is you get the data. It's not quite so much how you present it or how you store it or how you log it. It's just that you have it. So here's an image of a tunnel system at the University of Arizona. Each of the colors represents a different leg of this tunnel, and within the tunnel is, there's some steam lines and chilled water lines and some electric power and other utilities in there. And so this map ultimately has layers, and on each layer there's one of these utilities. So there's a pretty comprehensive mapping system that actually got started in the 1970s here and has been updated periodically. Recently, however, university, let's see if I can make that go. The university initiated a tunnel modeling program here. So what you see right there is the outside of these underground tunnels. That's concrete vaults that are somewhere between 5 and 10 feet below the ground. And then here's the inside image. This is then showing where all of these pipes are going. It's got the pipe sizes, it's got the accoutrements, the hangers, the traps, the valves. Everything's identified in here and logged in a database. So all of the components that are in this tunnel system are known. And from that, a couple of things can happen. So that's the...
let me comment on the tunnel system. You know, the whole concept of that, and that took place several years ago, a BIM analysis. We talk about our aging infrastructure. We also have our aging workforce. And we had 2 gentlemen who took care of our tunnels for over 30 years. And when I took over everything over 8 years ago, as I was doing an exit interview, I said, all right, you've harnessed all that information of where those valves are, where those challenges are in the tunnels. And they said, yes, we have. It's right here in my head. And they walked out the door. I called Henry up. I said, Henry, we need to get with another group, do a 3D BIM analysis of our tunnel. We need to capture every valve, every challenge that we have, and that will be part of our roadmap, our utility roadmap. Because as some of these pictures show, we have 6.5 miles of tunnels. We also prioritize those tunnels in terms of repairs with concrete spalling. And we have a researcher at the university. We'll have another slide here that will talk about what a product he developed, Quakewrap, that allows us to replace our tunnels and really recoat them at half the cost. And we've used that on several tunnels. We are allocating over $6 million in the very near future to address several of our aging infrastructures. And some of these tunnels, we've had a major challenge a year ago, right around the holiday break, that we had 8 inches of concrete lid collapse right on a major steam line. And fortunately, we were able to go ahead and get that repaired without any damage or interruptions to our campus community during the holiday break. So it's critical you understand where those challenges are and then also monitor them on a routine basis because things can change quickly.
Yeah, and I guess I just go back to that. You know, we saw that pretty looking BIM picture of how everything is. Reality is a little different than that. So part of our condition assessment in the tunnels is documenting these kinds of situations. Some of them look really, really scary, but you gotta look carefully at them and make sure that this is really a high priority. The case that Chris talked about, there was a visible crack right over top of this steam line, and sure enough, it caved in a couple of weeks later. So that was a high priority. Some of them not so much, but important though to document what they are, know where they are, and have that on the list, the entire list, not just a few of them. What are all the potential issues here? Then when you do your next capacity review, you can check off, we fixed this, we fixed that, we fixed that. We better go take a look at items 4, 5, and 6 because we didn't have money to fix those. Have those gotten any worse? Do we need to address them now?
I got to tell you, we love doing the checkoffs. That, you know, we establish a problem, opportunity actually, and we put plans in place to address it. And it's just not the older systems. We're finding, quite frankly, unfortunately, some of these newer systems, tunnels in the case that maybe not be that 60, 80 years old, maybe they're only 30 that we're having some challenge with water penetration. So we just have to make sure you have good, solid plans in place.
And so the tunnel, I think what we found here, some places it makes a whole lot of sense, just tear it up, start over. If it's out in kind of a green space, that may be the most cost-effective way, but we really have experimented with, and I think had some pretty good success with in situ repairs involving stripping the concrete off, epoxy crack injecting, putting in waterproofing foams, and then ultimately lining these things with carbon fiber, like a fiberglass thing, except it's carbon fiber epoxy lining. So what you see there in the kind of elliptical picture there is the finished product of the picture that's right next to. Actually, I guess you see the whole cycle there. We start with a big crack, we abate, we strip off all the way down to the rebar, we put in the foams, and then come back with epoxy. So a way to do this at about a third the cost of building a new tunnel. Not inexpensive, however. Another thing we do once we've got the whole system laid out, and we actually know what size pipes are what and how they connect and what the components are, we're able to do distribution flow modeling, which is to say we can really evaluate the capacity of the distribution system to move cooling or heating from one point to another, from one plant to the farthest building. And if you're going to add another building, we can simulate, will that be a problem? Do we need to do something or not?
It'll be interesting, too, as one of the questions came in. Do the colleges that are on the line, do you have tunnels within your systems? I know that larger universities, we do. Some of you may just have direct buried chilled water lines and such. If you do have some tunnels, just drop us a note, let us know.
Yeah, I don't want to linger on this, but a thing that's really evolving here and is taking hold at the U of A is putting everything in a GIS program, a Geographic Information System. And so here, this is really sort of a cohesive campus system, starting with the buildings, starting with the grounds, and going down into the level of buried utilities and tunnels. And what's really handy about this is you can get all of the components in one large metadata base in which you can manipulate it in any number of ways. So we really see this as the sort of the future of utility planning, enabling a lot of opportunities to do things in an automated, very efficient fashion. I guess what I want to caution you, though, is although GIS is a really interesting and developing technology, it also is very expensive, and you really got to evaluate what the return on investment in putting a GIS system is versus just getting down there, rolling up your sleeves, and getting a hand map together, figuring out what your priorities are. Of course, GIS, now that you got a GIS, you can put this on your phone. Just a remarkable amount of information can be available to you, which gets me to my little Tron image here. I don't know how many of you remember the movie Tron, but basically, it won't be long before all of the information that's in your utility system and a real-time fluid dynamics model will be in a computer or will be capable of being in a computer. We're not there yet, and I would tender it's probably not time to invest really heavily in that technology yet.
Did we put the music in? I don't think we included that in this presentation.
All right, so utility interface costs, I just want to briefly talk about this. I think this is something with these periodic capacity reviews is also an assessment of what the utility rates are, what the tariffs are, and what the opportunities are to buy long-term strips of gas. Really step back and look at, are we buying utilities the most intelligent way? That's our rate evaluation. Often we find these opportunities. At one time, our utility was charging a whole lot for what they called a ratchet demand clause. So the university came up with a clever way to avoid the ratchet command. That's something we call the red line, saving $500,000 a year. Well, then what happened is the utility comes up with another thing they can gig us for $500,000 a year. And sure enough, we figured out how to put in capacitor banks to solve that problem. So it's a little bit like a spy versus spy kind of a thing. Utility changes the rate, we figure out what the deal is, and then possibly make some adjustments in operation. But I want to say ultimately that's not the long-term strategy. You really got to look at your utility as having a long-term relationship, and you got to figure out what it is they've got that you need and what it is you've got that they need in order to set some long-range commitments that are mutually beneficial. Internal, I'm not going to get into this. This is just the importance of figuring out what your true cost of utilities is, how you allocate, not just pass through the energy costs that you purchase, but what are all your direct labor costs? What are your materials costs? How do you allocate your admin, your depreciation, And as Chris said, a number of ways to do this. Important that it's done so when you're selling utilities to your customers here, you're adequately allocating the cost to them. All right, finally we get to kind of the future state here. We're talking about, again, kind of breaking it down into production, distribution, and use. And, you know, the key kinds of things we look at, equipment renewal and improvements, equipment additions, changing technology. Recently, a technology change here was going from very large scale water tube boilers to much smaller scale but very quick reacting boilers, low mass boilers that made a large difference in the amount of sort of residual heat when the loads bounce up and down. We're able to follow them very quickly. A technological change. 10, 15 years ago, probably couldn't have done that. Now it's available. Apply that technology and instantly reap the return. In the distribution system, we look a lot at renewal. Sure, there's times when we're rebuilding tunnels, and we've done that a few times. Generally speaking, that's a very expensive proposition. And if there are ways to do it with, for example, this quake wrap technique, those tend to be a lot more cost effective. Go ahead.
Yeah, Henry, I mean, you bring up a critical points here in terms of looking at our overall distribution system, our production systems, and then also the prioritization of it. And as we look at the funding, we need to, or we'll be discussing funding, coming up with models on that on several different fronts, because you're looking at, as we've talked about, in some cases, millions of dollars for our infrastructure and then also for our building renewal. Some of those funding models, as we looked at, is it fees? Is it student fees that are allocated to address the campus infrastructure? At the University of Arizona, there's a student fee for IT upgrades, as that's changing at warp speeds. Should there be a campus utility distribution system fee? Should there be a deferred maintenance fee? Now, nobody likes paying fees. I have 2 children who are in college. I have a 3rd one coming. But also, we do need to make sure that the systems are well maintained. The University of Arizona, the $400 million that I talked about, there was a lot of reviews with our Board of Regents, with the state legislators, the president, naturally, our chief financial officers, and ultimately then the governor came back and said we need to go ahead and address these challenges. And we know the state funds have decreased dramatically for our colleges and our universities. And the fact that able to paint the story and having a solid capacity review in place, having roadmaps in place, and then having a financial model equated to that is prioritized, really allowed us to go ahead and work with the state legislators and getting additional funds at $200 million to address deferred maintenance and some infrastructure.
Yeah, just to wrap this one up, again, don't ignore the use. I think one of the ideas of renewing building equipment, replacing air handlers, heat exchangers, retro commissioning buildings, it's been remarkable the magnitude of savings that have been achieved in investing in aging buildings. And once you've achieved that savings, that then lowers the demand on the utility system, lowers the demand on the plant. So retro commissioning a building ultimately buys you more time before you got to invest in the next boiler or chiller, because you just freed up some capacity. You're not using so much anymore.
And Henry, that also then goes into the deferred maintenance of the building itself. Having a solid 10-year plan in place to address the deferred maintenance needs, air handlers, electrical upgrades, elevators, plumbing challenges that we have in the buildings, roofing. When you have those all prioritized, broken down, at the University of Arizona, we do an annual deferred maintenance review. A third party comes in, but also we are having our staff who have a wealth of knowledge on that. And we're benchmarking our dollars, our operational cost also, our utility costs against universities throughout the country. We have a group of peers, as you all do, and saying how efficient and effective are we in running our operation. And if there's other universities that are doing something better, as I mentioned, we're saying, how can we all learn together? And that's really part of this webinar today, is that we're all in the same challenge together. And it's great opportunities, especially as our square footage gets older. And let's share the information. And that's something that APA offers and does just an outstanding job of best practices and networking opportunities.
Okay, so we talk about identifying the projects, and there's a whole range of scale here. You know, this goes from the in-house initiatives. Chris talked about the apprenticeship program as kind of an in-house initiative. Another one here has been really upgrading the controls department. Automatic controls and automation folks have trained, become more educated, and are becoming very competent at taking over what historically had been outsourced programming and improvements. So yeah, scale goes from in-house projects, small job order contracting projects, to routine equipment replacement. I think we talk a lot about phased system improvements. This campus went through a 5 to 15 kV electric distribution improvement. Took probably 7-8 years. In fact, I think we're still on the last phase of this thing. But it was basically, well, we got to upgrade everything from 5 to 15 kV. We'll start in this corner where the need is greatest, and we'll work our way out. Slowly as funding, annual funding comes up, a little chunk of it goes to that kind of a improvement. Same kind of thing with tunnel rebuilds. Every couple of years, evaluate where the needs are, and go fix those. Probably not conceivable that you could fix all the tunnels in one big shot. Well, you don't have to. You just do it piece by piece. And then finally, major capital improvements that have to be planned and likely require Board of Regents approval or some very large investment, substations in collaboration with the utility company, a substation project. Often it's satellite plants where the campus has grown beyond the capacity of the original distribution system, and a satellite plant needs to be added. So I guess I just want to say utility roadmap and utility planning isn't just big projects and big capital improvements. It starts at the small scale and works its way up.
Well, it's critical too when you're talking the buildings. We have looked at our energy portfolio in the buildings. We can measure the energy intensity. That leads us to additional questions. Why is this building using more electricity, more steam than other buildings of similar type of square footage? You're basically detectives, and then you can get in there and say, how do we make more efficient operations? Low-lying fruit with our LED lights, to our air handlers with the variable frequency drives, to our fume hoods that in some cases are exhausting out 100% of air. Can we scale that back? And you can see a huge savings then in your chill water bill, your electricity bill. So there's just great opportunities when you have a good understanding of what's taking place in the building. But you have to have the team that understands that. There's so much data out there. You have to, on a consistent basis, the senior facilities officers have to pull their teams together and routinely make sure everybody's on the same page. And then the great collaborative effort between our financial officers, making sure they have a good understanding of what's going on. On a routine basis, as we get new business officers, we're taking them into our plants, we're taking them into the tunnels, sometimes in the very first time ever that they've seen a chiller, a 5,000-ton chiller, and what is that? And why is there $1 million put aside on that annual budget just in case of catastrophic failure? That's what it's going to take to maintain those. So it's a true collaborative effort on everybody's part.
Okay, and then another slide about sort of the rubber hits the road. We really have to demonstrate the economics of a project that's on the roadmap here. So we often do life cycle cost comparisons. We look at something that's got a 30-year life. We look at the operating expense and take a net present value of the expense and then compare that to an alternative. Often that alternative is, well, don't do anything different. Do nothing different versus alternative A. What's the net present value difference there? Alternative B. Kind of a tedious process, kind of the interface of engineering and economics, or engineering and finance. But ultimately, that's the kind of thing you got to be able to demonstrate that you've done, that you really have looked at the alternatives and made prudent financial decisions. So one of the things we're doing with these analysis is you set it up with a set of baseline assumptions, and then run it with a set of more conservative assumptions, and then a less conservative assumption. We call this stress testing the model, kind of like the banks when they were all collapsing. We're stress testing our economic model and see if there's something we're guessing at what's going to go on in the next 30 years. What if we're wrong in this area or that? Will our decision on what's the prudent thing to do change if we really don't have a very good crystal ball? So I think this is an important element of the utility master planning is economic analysis of alternatives, spending the time and sort of graphic energy to come up with something that really makes sense and can demonstrate to somebody who's not deeply involved what the differences in cumulative cost are over the life of a piece of equipment. That often is pretty astounding. Like, holy smokes, the difference in cumulative cost is tens of millions of dollars. That's the kind of thing I think that this level of detail ferrets out. Okay, and then finally, prioritizing, and this is kind of our roadmap. This is, we keep this kind of running trend of things that have happened in the past and what we're planning to do in the future. And again, it's all different scales. It goes from, doing an arc flash study, which isn't a particularly large scale kind of a deal, all the way up to, building a new substation. We look at this in terms of the utility system, sort of break it down by what are the utility systems, water, electricity, sewer, and so forth, air handler replacement. Or you look at it more on the order of by plant or quadrant of campus or department that it's serving. Or there's one that's called climate action plan. What are the improvements we're making that are going to affect our climate action plan? And there definitely is a lot of interrelationship in doing this kind of road mapping, where you're benefiting yourself from a climate action standpoint, you're benefiting yourself from a deferred maintenance standpoint, you're improving efficiency, you're increasing the capacity of the distribution system. There's a lot of sort of cumulative effects that aren't immediately obvious unless you lay it out in this kind of format. And once you've got all this data, I guess, sort of the big items, the big opportunities are, well, we could make a big move. We could look at adding cogeneration to the campus. We could look at adding energy storage, dispatch status strategies, or something I think is increasingly becoming an opportunity. We're certainly seeing that here in Arizona, and I think in the Northeast and probably the Northwest, this idea of a co-optimized utility-connected microgrid, where the campus itself, the infrastructure that is in the campus itself, is able to work consistently with the utility. So the first little image here is, what does the campus infrastructure look like? It's got generators, it's got storage, it's got controllers, regulators, and then how does that interface with the utility? Are there times when the utility really needs voltage regulation and could ask you to run your generators in a different mode in order to back them up? Or are there times when they become unreliable, and being able to island your campus completely, take it off, really provides a benefit, not just to the utility, but to the community at large?
And Henry, you the previous slide talked about assumptions, and the microgrid, we're going to comment on that. But it is, when you have priorities established, it allows the financial officers, the the facilities officers, when they have all the details in front of them, to then look at assumptions and do the what ifs. Yeah. We now have a good understanding of our metrics. We have a baseline of where we currently are. We have a roadmap in place to address all the utility challenges and opportunities that we have. As you mentioned too, if you want to drive your campus down to zero emissions, what will it take to get there? What's the cost? And then a lot of different assumptions play in then. If we bring a turbine in, what's the payback on that? What's the benefit? As we know, electricity continues going up, at least out here in the Southwest, I'd have to say throughout the country, and natural gas continues going down, and it's projected to be down for, quite frankly, years to come. I love that one model from the United States government of the energy portfolio of what it looks like in 30 years. And we're still looking at natural gas, and whoever would have thought that the United States would be a net exporter of liquefied natural gas. And so there's great opportunities there with assumptions. Microgrids, again, we had a previous webinar on microgrids, and there's now something hot off the press that APA will be partnering with ASHRAE on looking at microgrids on campuses. The University of Arizona is going to be one of the test areas, along with the University of Iowa, and we're going to be doing an analysis of developing a microgrid and how does that play in driving down cost on campus. So I know we have about 4 more slides and about 9 more minutes. So Henry, go ahead and.
Okay.
wrap up the rest of the slides?
This will wrap it up here. And I think this is the stuff we've been talking about all along, is kind of selling the need. And in our minds, and I think we've had some success here, Chris has had some success in this idea of really trying to bring this down to a simple little brochure, telling stories, marketing, talking about the reality of what we have now, what is on campus now, what are the opportunities to improve this thing, and what are the risks if it's just simply ignored. Continuity of operations, a huge part of meeting the university's mission. The image down below that is a sort of a graphic view of our roadmap here. A little bit small scale here, but you can see the periodic capacity studies. And from the capacity studies, the little lines are kind of reflecting the decisions that were made out of each capacity study. Here's a series of decisions that were made. And over time, you can see the sort of interrelationship of one decision that's made can impact 4 or 5 different utilities or systems or areas of campus. So finally, I want to show you this little brochure that we put together, which we're very proud of. So this is a little bifold, there it goes. Just a little fold-out brochure that has most of the material that we covered in this hour-and-a-half slideshow is within this little handy-dandy fold-out. Read this with your breakfast cereal kind of infographic. And so has it worked? Well, I think it's working. I think there's CFOs and boards of regents and legislatures that are able to say, you know, there really is some need here, and we best not ignore the potential risks. We best invest in this campus.
Henry, I believe as we wrap up the slides, I believe we also have some of our deferred maintenance slides in here.
Yes, I can find those.
And the one that would be helpful is to put the 10-year analysis. But what I'd like to do is just kind of check a couple key items here. One of the items that Wayne talked about as we wrap this presentation up over the next 6 minutes. If you have any other questions, feel free to go ahead and type them in. But the ideas for funding of our utility distribution system, and then inside the building for deferred maintenance. You know, over in Connecticut, the state legislators at one point in time did a bottle tax that they then were able to go ahead and use that toward addressing deferred maintenance needs on campus. What you see in front here is how do you keep deferred maintenance from nipping at our heels. This is one of the first webinars we did actually as APA president, and it's online. You can pull that up. But that also addresses those challenges of deferred maintenance and how we prioritize those. And so the one slide 13 would probably be a good one, Henry.
13.
Yep.
Right. And
so when you look at this prioritized the need on campus as a whole, all those critical mechanical, electrical, plumbing systems, and then we put a roadmap in place in terms of funding to start addressing it. As I mentioned, $200 million. We knew the dollar amount, and actually we have more needs than that, but it's a start. And then we said, how are we going to get the message out to our business officers and others? And so that has been very successful. So ideas for funding, bonding naturally is always an opportunity. And so there's different ways, but I would have to say the key critical item is that you need to make sure you have the message that everybody's clear on what the needs are on both the utility distribution and the mechanical, electrical, plumbing, deferred maintenance needs. Prioritization, again, this slide that you see in front of you, prioritize those key areas in terms of HVAC systems, safety, cooling, electrical, and such. The best practices that David talked about, the best practices that are out there, APA as a whole has a number of best practices that can be available on our webpage. Feel free to go there. And APA is all about networking. It's just a great association. I'm not just saying that as a president of APA, being involved with it since 2002. The educational opportunities for our facilities officers and our business officers, we have a great rapport with NACUBO throughout the country. Actually, we did a big webinar with NACUBO with our Chief Financial Officer, Greg Goldman, and myself and the University of Maryland on deferred maintenance and how we address those and how do we prioritize those funding. The question came up also about transformer maintenance and replacement. whether you're using infrared, whether you're using oil samples, it's critical that you have a good understanding of what your systems are, how many transformers do you have, what are they feeding, and what's the age of them, and when should they start being replaced. Some of them have PCB, and so you have some environmental issues that you need to address. The building systems, as we talked about, and the criteria of deferred maintenance. You know, when you're looking at criteria, breaking those down, you have the priorities. We talk in priorities 1, 2, and 3. What are the most urgent needs that could affect the continuity of operation within the building? That if it goes down, what is the catastrophic failure to faculty, staff, research, animals that you may have in terms of research in the building, students, and such. Some may have a medical center. You have to be aware of that. And then, as I mentioned, we have different webinars available with the detailed information. Again, apprenticeship programs play a role in all this, is having good, solid staff who understand how to maintain your areas. Again, that was another webinar that we did in establishing a nationally award-winning apprenticeship program. One of the questions came in is, could you take 34 colleges and come up with some purchasing consortium for electrical purchases or gas purchases? We work currently with another provider, used to be U.S. Energy, is now Kinetic, when we're analyzing our gas portfolio. And also we have looked at our Pac-12 schools and saying, could we, with the Pac-12, come up with a consortium and buying power on a larger scale? So that's an opportunity. And one of the other questions that came in too is, when you are addressing these priorities that need to be done, how do we go ahead and keep the buildings running? In some cases, if you're fortunate enough, you have surge space, you can move folks out, as we're doing in one building where we're gutting the entire building in terms of mechanical, electrical, plumbing. Others, you may have to bring temporary generators and cooling systems in. So I know we're getting pretty much on the time here. Tony Guerrero, it's always great, and Tony, as you know, is on the board with me. I appreciate all his services to his college and also to APA. And also to all other members within the Pacific region and throughout the country. Henry, we appreciate very much all your knowledge, your expertise, GLHN, and the business partnership that we have had at the University of Arizona on addressing our utility systems, deferred maintenance systems, literally for over 50 years. I think we have one more slide that just gives our information that we'll go ahead and put up here, and that was on the end of the last presentation we did. And if there's any other questions, please feel free to let us know. Our next APA webinar, which will be looking at our Thought Leader series that APA does on an annual basis. We have many different topics. The last one that we did in February of this year was on the risk potential at our colleges, community colleges, K through 12 in this day and age. And so it's looking at risk on campus. And also we have one that was on the total cost of ownership. And so that will be available. Henry, any final words before we wrap up?
Well, I just wanted to make sure we covered our original questions there. And you know, the one that I kept going back to is the question that was sort of like buildings versus infrastructure. And I just want to reiterate one more time, the way to look at this is not buildings versus infrastructure, but it's all one infrastructure. And you got to look at the soup to nuts, start to finish, in order to prioritize properly.
Henry, again, we appreciate very much GLHN support. All those who stayed online, and we had a great attendance, and everybody stayed online. Actually, once you signed in, you stayed. So hopefully you found the information helpful and valuable. And if you need to, you have our emails. And this day and emails too, feel free to give us a call. And so you can just go ahead and coordinate a time that Henry, myself, we could just do a conference call in person and talk to you. So thank you very much from APA. Great association. It allows us to transfer knowledge, harness and transferring knowledge to our new members and our current members. So thank you, everybody. We appreciate it very much. Hopefully this was helpful. Take care, Tony. Good hearing from you. And it looks like we got one more. How much of one of your roadmap success is due to the fact that you have a consistent relationship between GLHN and U of A, with changing consultants impact how? Thanks for your time, both of you. We appreciate that. And what I will tell you is we have multiple relationships with business partners. GLHN has been a solid partner. We have multiple relationships. It's a diversified portfolio, but like all of us, you have some business partners who you have business solid relationships for literally decades, and we do appreciate those partnerships. So with that said, thank you, everybody. We appreciate it, and we're glad it was helpful information. Bye-bye.